Let's continue with adding and subtracting fractions. So far, we have established a rule that allows us to add fractions like this, very simply. 2/7 add 3/7 is 5/7. We've spotted the rule that when the denominators are the same, you can just add the numerators. And we also recognised that's right, for subtraction, it works the same way. This is really crucial, and this principle of the same denominator will come in handy later on. We also looked at a curious case, which was 5/9 add 5/9, which, if you've seen the previous video, gave an answer of 10/9. Now, we followed the rule from before, so that's no problem, but something looks strange here. So I wonder what's happening. We also talked about an alternative answer of 1 1/9. So let's look at the following. Seven tenths and 4/10. Let's do a check. Are the denominators the same? Yes, they are. So we can use our rule that when the denominators are the same, we add the numerators, which gives us 11/10. A strange answer again. So like on the previous video, we're going to draw it out and try and get our heads around it. Two, three, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7/10. We're going to add 4/10 to it and see what we get. Oh, I added 3/10 to it and I made 10/10. 10 was the denominator and the number of pieces needed to make a whole one. And I have 10 pieces, so I have one whole one. But one of my 4/10 I'm adding is left over. So my answer is 1 whole one and 1/10. You'll notice here that I'm writing the 1 whole one big next to the small fraction. There is a good reason for that I'm now going to talk to you about. This fraction here is 2 whole ones and 1/5. What is this fraction? It could be 21/5, where I've forgotten to draw my line all the way across. Or it could be 2 whole ones and 1/5. If I have whole ones and fractions, drawing the whole ones large avoids this confusion. So it's a good idea. So let's continue adding and subtracting fractions. And let's check our basic understanding is all in place. I've got 3/10 and I want to add something to my 3/10. Whatever I add has to make it up to 1 whole. What could this be? There are actually lots of perfectly correct equivalent answers, but we want the simplest one. There is our whole one. Split into 10 pieces because I currently have 3 of those. Whatever I add on has to make it total 1 whole one. So what do I have to add on? Well, it looks like 1, 2, 3, 4, 5, 6, 7 tenths need to be added on. Could I have worked that out a different way? Drawing the diagram made it very easy. What over here gave me a clue that I was going to need 10 pieces. That's right, that denominator of 10. 10 pieces of this size makes a whole. I had 3 pieces. What do I have to add to that to make it a whole? Well, if 10 pieces makes a whole and I have 3, I need 7 more to make a whole. Now you can do these questions, like all of fractions, with the diagram or without. Let's try and do one without first. Look at the sum. 2 things added together makes a whole. One of those things is 5/9. What's the other? How many pieces do I need to make a whole? It's 9. How many pieces do I have? 5. How many more pieces do I need? That's right. I need 4 more pieces that are 1/9 in size, and they must be the same size because 5/9 add 4/9 using our rule is 9/9. 9 pieces are needed for a whole one, and I have 9 pieces, so I have 1 whole one. Let's try one more, but let's change things around a little bit. I have a whole one, and I want to take away 3/5. What will I end up with? Here is a picture of a whole one. What should I divide this into to make the question easier? 5ths. I have all of these in one whole one. Take 3 of them away. What am I left with? That's right, 2/5. Well done.